Hello everyone, I am Amit Guptani, Assistant Professor in Mechanical Engineering Department at Dr. Subhash Technical Campus, Junagadh. I welcome you all on today's presentation related with the subject Industrial Engineering. In today's presentation, we will discuss on the topic plant layout. So before we begin our today's presentation, let us have an overview of today's presentation. In today's presentation, we will study about definition of plant layout. Second topic is objectives of plant layout. Third topic, principles of plant layout. And fourth, types of plant layout. So let us begin our presentation with our first topic, definitions of plant layout. So before the plant layout, plant location is a must. Plant location means you are selecting a site at which you are establishing your factory. So after the plant location comes the plant layout. So in simple words, plant layout is nothing but the site which you have selected for the factory or the space in which you are arranging your equipments, machineries, tools, materials. That is simply called plant layout. Arrangement of those equipments, tools, materials in such a way that there is a smooth flow within that plant layout. So that is all about the definition. Now our second topic of discussion is what are the objectives of plant layout. So one by one we will see the objectives of a good plant layout. In that first one, flow of materials, man machine should be smooth. So how you are designing that layout, within that region, the material, the man, the flow of those parameters or those items should be smooth. There should not be any backtracking. There should be always forward movement of all those things. The second objective of a good plant layout is efficient utilization of available floor space. So once you have selected the site, you have selected the space, now you should effectively utilize those space in terms of length, width and height. So everything should be covered in an effective manner. That is called effective utilization of available floor space. Means workers can move freely without any interruption. Then material handling is minimized. So good plant layout should also be considering that material handling is minimized, as the raw material needs to be moved from one workstation to another workstation. So that must be taken care, thus material handling is minimized. Otherwise there will be a possibility of materials getting damaged. Next point, reduce congestion. Reduce congestion means there should not be any blocking or crowding of materials at one particular workstation. Next is waiting time for semi-finished product is minimized. So at one workstation, suppose the raw material is entering, and at that place one operation is completed. So it should move smoothly and in forward direction to the second workstation. There should not be inventory of that semi-finished product at one particular workstation. It should move from one station to another station in a straightforward and forward path. So again, just if semi-finished product waiting time is minimized, then ultimately the time required for the finished product will be also minimized. Next is reduce throughput time. That means from the first entry of the raw material at the first workstation to the last workstation, that should be minimum. There should be, if as we discussed in the earlier point, there should be reduction in conjugation, there should be reduction or minimization of in process inventory, so that ultimately will reduce the throughput time. Throughput time means total time taken to complete the product from the starting to the end point. So if all those discussed parameters such as congestion, then waiting time of semi-finished products is minimized, then ultimately the product will be produced in a much faster way. Next is ease of working, maximum safety and minimum health hazards for people working. Okay, so the environment at which or the place where they are working, their safety must be considered, then there must be minimum health hazards, means those temperatures at which they are working, there should be those temperatures should be accordingly, so that they can maintain their enthusiasm. Then maximum safety, if there are vibrations, then that must be bearable to them, otherwise it will cause fatigue to the workers and ultimately their production will be affected. So all those parameters must be considered, such as environmental conditions, working conditions, their safety. There must not be any fumes or any odors at where they are working, that will again affect their production. So last, flexible for accommodating minor variations. Now your plant layout design should be such that if the demand increases suddenly, and within that design plant layout there must be in a situation to accept that increase in demand, or whether the product's design is slightly changed at that time, within that layout that must be in a position to be accepting those minor changes, so that the layout should be flexible. Next, third topic, principles of plant layout. The first principle is principle of integration. Principle of integration means all those factors such as man, machine, tools, equipments, they must have workers, they must have smooth flow, and they must have integration within, means they must have a good tuning within, so that ultimately the production will not affect. So their production will not be affected. There must be tuning within, there must be proper integration, so that all the resources are utilized in an efficient way. So that is the first principle, that is principle of integration. Then second, principle of minimum movement. Okay, so there should be minimum movement of materials and workers. They should travel minimum distance, so that they can give their work in an efficient way. If workers are moving from one place to another place, they are traveling more within that particular layout, and ultimately they will get tired. So this must be also considered. Materials should move as minimum distance as possible, and labors also. The third principle is principle of space. So whichever the space that has been selected, they must be effectively utilized in terms of horizontal and vertical distance. Means if they want to stack or they want to have the inventory of materials, then they can stack one over another the materials in a vertical direction also. So that should be utilized both in form of horizontal as well as in vertical way also. That space must be utilized in both the ways. That is called principle of space. Then principle of flow. So they must be arranged in a sequence based on the operations required. They must be arranged according to the sequence of operations that you need to do upon the product, so that there is no interruption and flow is always smooth and in forward direction. There is no backtracking. That is principle of flow. Then principle of safety. The places at which they are working, they must be ventilated, there must not be any fumes, noises. Any fumes, noises, odors, dust. The working environment should be pleasant, which ultimately will help them to operate at higher efficiency, and their efficiency will also increase. The workers' efficiency will also increase if the place at which they are working, they are well ventilated, there is no any unwanted noise, then there is no fumes, means gases, then odors means bad smells are not there, then that will increase their efficiency ultimately, and that will ultimately help them to get more out. So that is principle of safety. Then principle of flexibility. So that particular layout should be in a position to adopt or accommodate the changes, whether that product in the market is totally obsolete, then if you are adopting some new design or some demands are increasing suddenly, at that time within that layout or with that particular layout must be in a position to accept or accommodate that minor changes. So that is called principle of flexibility. It is given with an example in an automotive industries. As we know, in automobile industries, after 2 to 3 months or 6 months, there are always new models that are launched by the company, 6 months or 1 year. Then there must be change in that particular design. So that layout must be able to accommodate that minor changes. Okay, last topic, types of plant layout. Mainly there are 3 types of layout that we will discuss. The first one is product layout, also known as line layout. So we will see 3 types: product layout, process layout and fixed layout. So we will start with the first type of layout, that is product or line layout. So in this type of layout, based on the requirement of product, accordingly the machines will be arranged in that sequence. Suppose, for example, if a product requires 3 types of operation, that is lathe on lathe machine, one on milling machine, and last on drilling machine. So accordingly that machines will be arranged in that particular sequence which is required. Only the 3 operations are required on that particular product, so that machines will be arranged according to that sequence, first, second and third, and afterwards you will get the finished product. So based on the requirements, accordingly the machines will be arranged. So under this, machines and equipments are arranged in one line depending on the sequence of operations that are required for the product. This type of layout is preferred for continuous layout, and there is no backtracking or deviation. It moves from one workstation to another in a sequential manner. These types of layouts are adopted for food processing unit, paper mills. Paper mills means papers are produced from the bamboo tree. Then raw material is bamboo tree, and doing that raw material enters from one side, then some operations are done or some processes are done, and at last that papers are coming out. So this is explained in the figure. There are, as I said, a product layout is one in which machines are arranged according to the requirement or according to the operations that are required to be done on the product. So here we have taken examples of two products. For product 1, from the left side the raw material enters, then the first operation that takes place, that is on lathe machine, second operation takes on drilling machine, third on grinder, fourth on assembly, and fifth it is going to the painting section where painting is done and finished product comes out at the right side. Similarly, for the second product or product B, the first operation takes place on the planer machine, then on second on grinder, third on miller machine, fourth on lathe machine, sixth welding, and at last it comes out in the form of finished product. So in this type of layout, those machines are arranged according to the operations that are required to be done on the product. Now we will see the advantages and disadvantages of product layout. The main advantage of this type of layout is it is used for continuous production, means high rate of output. Then second advantage is low cost per unit, means as you are producing it in huge numbers, so it is but obvious if you are producing more amount of product, their cost per unit will be less. Then it utilizes the floor space in an optimum way, continuous flow of work, product completes in lesser time because there is no backtracking. Once you have inputted the raw material, it finally comes out in the finished product or in finished form. There is no backtracking because machines are arranged in that particular sequence. So once it comes inside, it comes out in the final way. The disadvantages are it requires higher initial capital investment as there are special purpose machines, because based on product accordingly the machines will be arranged depending on the requirement of product. So special purpose machines are required and it ultimately requires high investment. Second disadvantage, so if any machines within that layout fails, suppose for example there are 5 machines and if any one machines fail or breaks down, then the whole production line will stop. So this is again a disadvantage. Then it is lesser flexible, because if the product will change, then accordingly you will have to also change those machines, so it is less flexible. Okay, this is all about product layout. Then second comes process layout. In this type of layout, for example, there are 3 sections. Suppose one section is of lathe machine, so in that particular section there are number of lathe machines. Then second is for example milling machine, in that section there are number of milling machines. Then third for example is welding section, in that there are number of welding machines. This particular type of layout is employed in batch type of production. This type of layout is also adopted in hospitals. So let us understand this type of layout with the help of figure. See, we are having 2 products, product A and product B. So for the first product, first operation is drilling, so we are taking the raw material to the drilling section, then it goes to planning section, then it goes to milling section, for the milling operation, then it goes to the welding section, then it goes to the grinding section, and then ultimately it goes to the assembly department where it is assembled and it is taken out in the form of finished part. Then for the product B, it first goes to the milling section, then it goes to drilling section, then it goes to planning section, then it goes to welding section, then it goes to grinding, and finally to the assembly department where it is assembled and taken out in the form of finished product. So what is the advantage of this type of layout over product layout? As we had seen in the previous slide, it is adopted in hospitals. So when the patient comes with an accident or broken leg, then according to the function, according to the requirement, it is moved to that particular function. It directly goes to radiology department where x-rays are taken, then it goes to the dressing room where plaster is done, and so and so. So now we will see advantages of process layout. The first one, reduced investment on machines as compared to product layout. In product layout, we were supposed to have special purpose machines, but in this case, in process layout, we are having general purpose machine. So it is reduced investment, initial investment. Second, it is greater flexibility in production because there are different sections that may be of milling, that may be of drilling, that may be of welding. So if you require only two operations, then in two departments that particular raw material will be moving for the operations. So greater flexibility. Then handling of breakdown of equipment is easier. Okay. So if any machine fails, as we discussed in this type of layout, there are sections. Suppose in that section we are having 5 lathe machines. So if any one machines get breakdown or it gets failed, then you can utilize other machines also of that particular operation. So breaking down of any machine will not stop production line because at every sections we are having more than one machines of that particular type. So breakdown of machines will not stop production line. That is again an advantage. Then one more advantage, that is if one worker is carrying lathe operations and he is not affected by another worker working in another section. For example, one worker is doing operation on lathe and another one is doing operation of welding. So both the departments are far away from each other, so rays of welding will not affect the worker which is working in the lathe section. But in case of product layout, suppose two machines, first operation is lathe and second one is welding, so that both operations are arranged in the same sequence, so it will affect the workers. But in this case, both the sections are away from each other, so will not affect. Disadvantages: this type of layout requires more space. Yes, that's right. Then production time is increased because of extra travel. Yes, here the production time will be more because the materials will have to move from one section to other section. So material handling cost will also increase and time will also increase. And there are also chances that semi-finished products may get damaged. So production time is increased because of extra travel. Work in process inventory is high, needing greater storage space. As we discussed, okay, semi-finished products, suppose at first operation is done on the lathe machine, that is at lathe section. Then for the second operation, that particular semi-finished product will have to be moved to some other section. So that is work in progress inventory, which needs a special storage. And last, chances of semi-finished product getting damaged, because that semi-finished product have to travel from one section to other section, and there is possibility of some casualties from workers, so that there are chances of the semi-finished products getting damaged. Now, third and last, fixed position layout. As the name itself suggests, here all the machineries, all the equipments, man, materials will have to be brought at particular site for making the product. Best example is manufacturing of parts of shipbuilding, which are very large. So at that particular site, everything has to be brought over there. Man, machine, material, equipments are to be carried over there at particular site, and at that place you will have to do the manufacturing of that particular product. Examples are of shipbuilding, aircraft parts, then boilers, turbines, road buildings. Best example, that is road building. Wherever we are making a new road, at that place all the materials, all the workers, all are brought over there, and they will ultimately do the work at that particular selected site. From the figure, let us understand all the labors and equipments are brought to that particular. Here it is shown in figure at shipbuilding yard, where ships parts are to be built. All things are brought over there and manufactured over there, and finally the product is obtained in final form. So now we will see the advantages. Investment on layout is small because you will have to go to that particular site, so investment is less. Then a number of quite different projects can be taken with the same layout. Yeah, you can make different parts, different shapes over there. Then worker takes pride when the work is completed. They feel proud for themselves that I have achieved something. That is again an advantage for them. Now disadvantages: capital investment is quite heavy because all the machineries, everything has to be bought over there. Then it must be stored properly over there. There must be rent provided for that particular site. Then very large space is required for storage of equipment and materials. Yes, those equipments and materials for storage requires very large space, because if you require machineries for production and that machineries are bought over there, then you will require space for them to accommodate. So that is again large space will be required, so that is again disadvantage, and work completion time requires a lot. Okay, thank you.